Hello, this is Mr. Rumpf. We are going to continue on with simplifying rational expressions here. Don't let the tone of my voice throw you off. This is going to be as exciting as it sounds. You can see that because there's an exclamation mark. Now, we are going to add factoring into the mix. Let's go. So, first problem here, x squared minus x minus 20 over x squared plus 7x plus 12. We want to simplify this. What do we do? Great question. Glad you asked. Well, first we could say, well, let's just go ahead and cross off the x squareds, the x, 20, this becomes 10, 12, this becomes 6, oh wait, this becomes 5, and this becomes 3, and we're left with 5 over 7 plus 3. Wait a minute. That doesn't make any sense. So, we can't do that. So what we want to do instead is we want to factor. Because remember, as we saw in the first video, the only way we can cancel things when we have rational expressions is if everything is a factor of the numerator and the denominator. Then we can cancel that factor. So we need to factor the numerator and denominator. I want you to try that on your own first because we need to remember how to factor. So go ahead and pause the video, try to factor. See if you can simplify from there. If you can't, that's okay. Unpause when you're ready to check at least the factoring though. Pause now. All right, so hopefully you ended up with x minus 5 times x plus 4 over x plus 4 times x plus 3. Remember, the order in which we write these factors does not matter. So if you had the x plus 4 and then the x minus 5, or the x plus 3 and then the x plus 4, perfectly fine. If you are confused on how I got that, recall that when we have a quadratic trinomial, we want to think about what multiplies to this number, so what multiplies to negative 20, but adds to the number in front of the x, which in this case is negative 1. So negative 5 times 4 is negative 20, negative 5 plus 4 is negative 1. On the bottom, denominator, what multiplies to 12 but adds to 7, 4 times 3 is 12, 4 plus 3 is 7. Excellent, great work. So now we want to simplify, and we see that I have a common factor of x plus 4 in the numerator and a common factor of x plus 4 in the denominator. So those are going to reduce, and I'm left with x minus 5 over x plus 3. Boom, that's my answer. Any questions? No? Good, let's move on. Next one. Here, we've got x to the third plus 3x squared minus 4x minus 12 over 2x to the fifth plus 16x squared. So we need to try to simplify. Again, we can't just start crossing off x terms. Like I see, oh, I've got an x squared and an x squared. I can't do that. It doesn't work. Because of the addition and subtraction here, those are not factors of the entire numerator and entire denominator. So what do I have to do? I have to try and factor. Again, I want you to try this on your own. Pause the video. See if you can factor the numerator and the denominator. If you can't or you get stuck, that's okay. A couple of hints. Notice that the numerator is 4 terms, so we're going to factor by grouping. The denominator is 2 terms. So just like with any type of factoring, I would look to take out a greatest common factor first, and then see if I can factor the result as well. So again, go ahead and pause the video. Unpause when you're ready to check. Okay. So my factoring, I'm not done with the problem, but the factoring part of the problem, I should end up with x plus 3 times x plus 2 times x minus 2 over 2x squared times x plus 2 times the quantity x squared minus 2x plus 4. And maybe you're wondering, how the heck did he get that? Great question. Okay, so my hint beforehand was factor the numerator as by grouping. So I grouped the first 2 terms, and now because the third term was minus, remember I'm going to make that a plus, put my parenthesis here and bring the negative inside. So I make this plus a negative 4x and then minus 12. So this is my second group, this is my first group. From the first group, I have a common factor of x squared. So I take out an x squared and I'm left with x plus 3. From the second group, which is negative 4x minus 12, I have a common factor of negative 4. Now remember, I also have a common factor of positive 4, but I know I want the result to be x plus 3. So I know I've done this correctly because what's left over in both parentheses is x plus 3. So that's good. Thumbs up. In the denominator, I notice that I have a greatest common factor of 2, because 2 and 16 both have a factor of 2, and x squared, because x to the fifth and x squared both have a common factor of x squared. So I took out a 2x squared. Now, what I'm left over with in the denominator was x cubed plus 8. Conveniently, that is the sum of cubes. In the numerator, I took out the x plus 3, so I'm left with x plus 3 times x squared minus 4. Now maybe you don't remember, the sum of cubes if I have something of the form a cubed plus b cubed, which for my problem I had x cubed plus 8, but 8 is 2 cubed, then this becomes a plus b times a squared minus ab plus b squared. So if I translate that here, this becomes x plus 2 times x squared minus 2x plus 4. So that's how I got the denominator here. X cubed plus 8 became x plus 2 times x squared minus 2x plus 4. The numerator, x plus 3 times x squared minus 4, conveniently, x squared minus 4 is the difference of squares. So if you don't remember the difference of squares, this is one of those patterns we've seen quite a bit. So this is if I have a squared minus b squared, which in our case was x squared minus 4, and 4 is 2 squared. This becomes a plus b times a minus b. So this became x plus 2 times x minus 2. And so that is how I ended up with x plus 2 times x minus 2. Now remember, another way to do this problem is to treat it just like we did on the previous problems, and I can think of what multiplies to negative 4 but adds to 0, because I could have thought of this as x squared plus 0x minus 4, and then that would factor into x plus 2x minus 2 as well. Different way to think about the same type of problem. All right, so that was the factoring. Now we're almost done with the problem. Now I can see x plus 2, x plus 2. Those both went away. And so now I'm left with x plus 3 times x minus 2 over 2x squared times x squared minus 2x plus 4. That is more simplifying rational expressions. And just to sum that up quickly, so basically we want to look and see, can we factor? And if we have common factors between the numerator and denominator, those are the things that we can reduce. We need to just remember all of our factoring techniques from our polynomials unit way back in first semester. And also remember, always look for a greatest common factor first.